question you would ask here would be, what is the current in this circuit? Is the current in all these objects the same or are they different? Same. The same. So we're in a single loop circuit, and that's going to mean that the current is going to be that way. So, it looks like she's sleeping, so maybe she's secretly awake. That's how we sound. She's laughing now, so I can see that she may be awake. So, anyways, we want to find the current in this circuit. What we do know is always going to be true is Kirchoff, I don't remember if it's called the loop or the voltage rule, it's one of those two, but it says that all of, as you go around the circuit, depending on you're a positive charge, all of the voltage drops across the circuit have to add up to 0. Okay? So, we're gonna, this is our law. It says that delta V across the whole loop is always going to add up. The sum of delta V adds up to 0. So we're going to go around our circuit, we're going to add up all of the drops for all the gains in the circuit, and that's going to give us 0 by the time that we're done. So again, that's natural equation. If it's more complicated problems, there'll be multiple equations and multiple currents and multiple substitutions, and it's going to be a little hairy. But the simple case is relatively simple. At this point, unless it says something different, you're always going to pretend you're a proton. That's what we did at the 1990s. We put us in that position, so you can person to that way if you want. But we're always going to pretend that we're a proton. So we're always going to move with that in mind. And yeah. When you start these questions, the first thing you do is you just pick or guess which way you think the current's going to go. It makes no difference what you guess in terms of being right or wrong. It's going to affect what you do with your positive and negative signs and setting up your equation. But in terms of being the right answer, a wrong guess won't hurt you. Okay? So let's do that. Let's guess. We'll tell you now, I'm going to intentionally guess wrong just to make you one. Okay? So don't be confused by this. So I'm going to guess. So logically here, I would guess it's going to go counterclockwise. The current for that battery state. But we're going to guess wrong just to show you what's going to happen if you guess wrong. So I'm going to guess the current's going in a clockwise fashion. So the positive charge will go around the circuit that way. Okay? So you have to pick somewhere to start. Typically, you would start right behind the battery. That's just what we typically do. We're going to call this battery number 1. We're going to call this resistor number 1. We're going to call this battery number 2. We're going to call this resistor number 2. Is that okay? Yes. Good. So it wasn't organized. So we're going to start right here. If a proton or a positive charge carrier goes through a battery that way, you think it's going to gain or lose energy / voltage. Good. Whenever the positive charge goes out the positive end of a battery, that means it's going to gain energy from that battery. It's going up the correct way. As opposed to over here, it's going to come in the positive end, we're going to say it's going to lose energy fighting against the battery. So the positive charge wants to repel from the positive, it's going to be sped up, energized that way. If it comes into the positive, to fight against nature, and that's when we're going to work so well for it. So, we start off, we can just say that the sum of the voltage drops, sum of the change of potentials, is going to be V1, maybe the first one, but add the rest of everything. I'm coming around the loop, I go across this resistor. Resistors will always take energy away from me, so that's what they do. But how do I find the amount of voltage a resistor takes away? Ohm's law, very good. I know that V equals I times R. Agreed? Great job. And so I'm going to subtract I1 times R1. Questions? Free time to ask. Do I have a question? All right. Now this question I think was why are we subtracting that? Is that what you asked? Did I think I heard you correctly? We're subtracting it because resistors always take away energy from the charge. Okay? If you, yes, Dave. We're solving for the current right now. Good question. Anything else? We'll get to, no, we'll change that. But there are more than, I'm doing it now to make that happen. Good point then. Okay, now I'm going around the circuit. La, 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 la. I get over here now. I'm going into that battery from the positive side, trying to go out the negative. Is that the quote-unquote correct way or incorrect way? Incorrect. A positive charge carrier, so we're assuming we're a positive charge, would not want to go into the positive end of the battery. They would want to repel each other. So I have to subtract the potential difference that I would get is 2. I'm going to lose that energy. Okay? And this is why you don't want batteries facing each other in a device. It doesn't work very well. Question?
No.
Okay. Coming around the bottom then, I'm coming across R2. Am I going to gain or lose energy from R2?
Yes.
Lose, the resistor take it. So I'm going to do minus I2 R2. What's that whole thing have to equal? I'm back to the start now. The whole thing has to equal 0. Questions about that? Sarah? Agreed. We'll do that in a second. The reason, so this is what Lucy asked also. The currents here are absolutely going to do the same thing. I put those subscripts there to make the point that if you get into more complex problems, where you're going through lots of places, because sometimes a circuit will be maybe up to 4 loops in one circuit. You're going to be going through different branches where the current might be different in different places. So you do have to make sure you're keeping track of the current. After you make all your loop equations, that's the point where I was going to start saying those kind of things to yourself. In this particular problem, I know that as we're saying here, that I1 and I2 are going to be the same because they're in a single loop together, in a single series circuit. So I can, at this point, I can take those subscripts off of those two if I wanted to. If you can, and if you're smart enough to see that when the problem starts, feel free not to write them. I would just, think. So at this point, we know. All right, other questions? Now I'm going to solve for I. It's only one of them now. It's helping out a lot. Now, if there are 2 unknowns in a problem, what does that mean I need? If you have 2 unknowns, you solve it. You need how many equations? Equations. So if there were 2 currents, that means I have to make at least one more loop in order to solve that, and end up doing some kind of substitution involved thing. And it gets very dicey. Or you start making a bunch of junction rules also, because you'll have junctions. You'll have I1 plus I2 equals I3 and stuff like that as you get more complicated. Yeah, not today, but eventually, yes. That's kind of the end of the chapter. So, we know, at this point, we know the voltage 1, we know resistance 1, we know voltage 2, we know resistance 2. Those are all given to us in the picture, and so we can rearrange algebraically and solve for I. Agreed? So, yeah, we can do V1 minus V2 equals, I'm going to combine the I's and R's together, move them over to the right. So that should be something like I times R1 plus R2. A couple steps together there. Is that correct?
Yeah.
So then I have V1 was 6 volts minus 9 volts divided by this. Does anyone know what those were? 40 ohms plus 20 ohms. So that's 3 over 60 and 1 over 20. Right?
Negative.
Right, of course. The 0.05? That seems too small. 3 over 60. You 1 over 20? 0.05, right? Okay. Negative 0.05 amps. Questions about that? How we got that number? Now, the fact that if ever going to current, the current should end up being positive. You get a negative current, that does be left down, but that's all it means. So that means actually the current has been going counterclockwise. The number wouldn't change. Just going to get a wrong sign. The current will be positive. So get a positive charge. Yes, no. You can leave it negative, and then at some point it's going to ask you which way was the current flowing. You might have to go back to part A or somewhere. You have to make sure that everything is right. Yeah. So that's how you use Kirchoff loop rule.